So here we need to resolve the given rational fraction into partial fraction. So let us begin. Now, at the first glance, it seems like we only have two factors in the denominator, and both of the two factors are quadratic in nature. One is x squared plus x minus 2, and the other one is x squared minus x plus 2. So what we can do, we can either start with 1. So let's say we have 1 over x squared plus x minus 2 multiplied to x squared minus x plus 2. So what we can do, we can consider two partial fractions. One of the partial fraction, the denominator is going to be x squared plus x minus 2. And the other partial fraction is going to have the denominator x squared minus x plus 2. Now, in the numerator, what we can do, since it's a quadratic factor, we have ax plus b for the first partial fraction, and for the second partial fraction, we have cx plus d. So this is how we can resolve the given rational fraction into two partial fractions. However, if you want, there is another way. Here, x squared plus x minus 1 can be actually further factorized in the form x plus 1 multiplied to x minus 2 using standard method. So that means if we use this particular factorization, then we should get three factors or three partial fractions. That means we have 1 over x plus 1 multiplied to x minus 2 times x squared minus x plus 2. So here what we have done, we have factorized x squared plus x minus 2. So this is going to give us three partial fractions. The first one will be a over x plus 1. The next one is going to be b over x minus 2. And the third one is going to be cx plus d. Since we cannot factorize x squared minus x plus 2, this will be simply divided by x squared minus x plus 2. So there are two ways of going about this problem. We can either go the first track, so this is one way. So we can go either by solving 1 or we can go by solving 2. Both of them are going to give us the same result. So what we'll do, let's go with number 2. So what we'll do, we'll take equation number 2 and we're going to multiply both sides of the equation with the denominator on the left hand side. So that is x plus 1 times x minus 2 multiplied to x squared minus x plus 2, such that we immediately get the value 1 on the left hand side. On the right hand side, we have x minus 2 multiplied to x squared minus x plus 2 times 8. The second partial fraction after cancellation will become x plus 1 multiplied to x squared minus x plus 2 times b. And then we have cx plus d, so this will be get multiplied to x plus 1 times x minus 2. What we'll do, we'll expand the right hand side and we're going to combine all the like terms. So we'll get x cubed and its coefficient is going to be a plus b plus c. Then we have x squared with coefficient a minus 2b plus c plus d. Then we have x with coefficient 3b minus 2c plus d, and then we have 4a minus 2b minus 2d. Fine. What we do is immediately we can observe here that on the right hand side we have four terms. The first term contains the term x cubed, the second term contains x squared, third term contains x, and the fourth term is the constant term. Whereas on the left hand side we only have a constant term 1. So what we can do, we can rewrite it as 0 times x cubed plus 0 times x squared plus 0 times x plus 1, such that we also have four terms on the left hand side as well. Now what we'll do, we'll equate and compare both sides, and that's going to give us few equations. We'll have a plus b plus c equals to 0. Then we have a minus 2b plus c plus d equals to 0. Then we get another equation, 3b minus 2c plus d equals to 0. And then 4a minus 2b minus 2d equals to 1. So what we're doing here, we're trying to compare the coefficient of x cubed on both sides. So a plus b plus c, which the coefficient of x cubed on the right hand side becomes equals to coefficient of x cubed on the left hand side. That's simply 0 because there is no term containing x cubed. What we have done is we have just added this term 0 times x cubed. Similarly, we have found out the coefficient of x squared, which is a minus 2b plus c plus d, and equated with 0 on the left hand side. We do that for x as well, and then the constant term 4a minus 2b minus 2d, that's equals to 1, because 1 is given to us. So we have 4 unknowns a, b, c, d, and we have 4 equations. We can solve all these 4 equations to obtain the value of a, b, c, and d. That I will be leaving as an exercise for you to try out. So I'm all going to state the values of a, b, c, and d. So here a comes out to be equals to 1 over 6. B has the value negative 1 over 24. C is going to be equals to negative 1 over 8. And our value of D is going to be also negative 1 over 8. So what we'll do, we'll substitute this value back in number 2. So 2 is now going to give us, we have 1 over, so here x plus 1 times x minus 2, that's simply x squared plus x minus 2 multiplied to x squared minus x plus 2. That was our original rational fraction. So we have a over x plus 1. So a is 1 over 6. So we have 1 over 6 times x plus 1. Then we have b over x minus 2. So that's negative 1 over 24 times x minus 2. Then we have cx plus d. So both are negative 1 over 8. So we have negative times x plus 1 whole divided by 8 multiplied to x squared minus x plus 2. So what we have done, we have successfully resolved the given rational fraction into 3 partial fractions.